All right, everybody, this is Mr. Wyrick, and I'm coming to you from my kitchen, trying to get some stuff ready for tomorrow, and I'm going to go through these notes with you. So just real quick, I'm going through the first part of the 1.5 notes. What is a function? That's the stuff that's y equals f of x. It makes the graph. We usually have those points connected, but they don't have to be. It passes the vertical line test. It has inputs and outputs. There can be many different types, okay? So we got through reading the table. We talked about what would our input and our output be from that table. So the input is kind of what you've accepted as your x value. The output is what you've kind of accepted as your y value. So on the very first one that we had there, it was your input was number of hours slept a night, and then the frequency was how often someone answered that question, okay? And then when we looked at the graph, it was like a dot plot, but only the top point of that dot plot was existing. And it looked kind of like a parabola across there. And our inputs were like 6, 9. So if the number of people who said they slept 6 hours was 9, or 9 people said they slept for 6 hours on the night, on a school night. And we talked about having the function notation. So f of 5 equals 6, f of 9 equals 5, and what that would mean. So today, we're going to have a short assignment about, that was yesterday's, the assignment about modeling distributions and functions. So real quick, I'm going to pop to Schoology, and I'm going to talk about that. So if you want to kind of move over into trying to look at those questions, I will hit the preview on this one and we can take a look. So the first question, asking about the graph with the car, the bus, the walk. Car was the input, 2 was the output. On the very next one, f of bus equals 35. That would mean 35 people are taking the bus. So bus is the input. That's the one we're looking at. And the output was 35. Question number 3, if f of walk equals 4, that means that 4 people are going to walk to school. The survey of the 80 students in the Intro to Statistics course. The domain, and again, it's kind of like the label of the domain on this one. If the question is asking how many semesters they have completed, the domain of that would be the number of semesters completed. That's what we are looking at. That's our descriptive thing there. That same survey question, one student said the data distribution could not be a function because many students had not completed a semester yet. You should have disagreed with that. Most of you, this is your freshman year, you have not completed a semester of high school, but you are a high school student. So 0 is a viable input. This would still be a function. It's just like having a y-intercept. Then the question had students list their favorite car color. Which one of those responses would be correctly using function notation? That would be f of red is equal to 10. Then we have the dot plot. 15 minutes should have been 4. And that was one that I think was wrong on the key. So if you got one wrong, this might have been it. And it should rescore them by tomorrow, hopefully. And then the number of students who took 5 minutes was also 4. And then question number 8. The box plot can be converted to a function. What would help describe the changes? So if we're looking at it, we wouldn't leave all of these points. It's actually a dot plot, not a box plot. My bad on the typo. Only the top point is what we would leave on there. So that's one of the ones that would help describe the change. The dots could be connected. I made sure to put could. You wouldn't necessarily have to do it. But you could connect those dots to make it look like a more traditional function. It would change colors, doesn't make any sense. And you can still tell the frequency with which the answers were selected. On 35, we would still have that 3, so it would be good times. Okay, so having gone through that, let's go ahead and jump in on what we are working on today. So day 2, we're going to take a look specifically at histograms being used as functions. So these are some things you'll have to kind of answer as we're going through. What would this information look like in a histogram form? How could it change? I know there were some people, if you were in Mr. Stanton's class, that they went ahead and made histograms for this. And because it's kind of a 1-to-1 ratio, it wouldn't look that different, but it looked closer to what a bar graph is. It would still fit into that curve shape. We could still determine a function from what's going on there. So now on the your turn to practice, you do need to do this. So kind of pause this video when you get to this point. Create 2 different histograms using this data. Make them different by adjusting the bin width. Some of us had some trouble messing with the bin width on the test, so make sure somebody at your table can help you if you don't know exactly what it's talking about when it comes to adjusting the bin width. So if we are looking at the bin width here, it has the height. There are 40 different entries there, so that's a good size list. Go ahead and title the first list as F. Put this as F. We'll use it as a function, so the letter F is going to work well. So put all of those in there and make 2 different histograms from this. So you might just, after you've entered them all, make sure you have 40 entries on F, copy and paste that down and make that second list, retitle that one as G, and then go ahead and make a histogram of F, a histogram of G, and then adjust the bin width. You might go with 5 on one of them and 10 on the other. You might go with 2 on one of them and 4 on the other. Just some heights that you think kind of fit together pretty well. Yes, and then the next page. Call your first histogram F, your second one G. If you treat them as functions, and this is stuff that you should write in your notes, you should differentiate between those 2 histograms and talk about what's the difference between the shape of the 2. Do they have the same shape? And what is the reasoning for that? Okay. If we treat them as functions, what would be F of 60? What would be G of 60? So you're having to read everything that's in the column that contains 60. You should probably make sure that those are left aligned on the histogram just for some consistency. But for instance, if you're doing 5s and 10s, just looking back at this list, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you did bin widths of 5, F of 60 would probably be around 11. I'm just estimating really fast. And if you were doing bin widths of 10, F of 60 would be 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, maybe even around 23, maybe a little bit more, maybe a little bit less, okay? If we're looking at that, the reason why is we are grouping them together. So that column that sits on 60, and 60 is the left boundary for it, is going to be only so tall if you are grouping them together by 5s, because it would be 60, 61, 62, 63, and 64. But F of 60, if you're doing 10, would be 60 all the way up, and then the next column would start at 70. So you're including a bunch more numbers in that spot. So you should have different outputs for these no matter what you're doing. If you're grouping by 2s and 4s, if you're grouping by 5s and 7s, if you switch from 2s to 5s, okay? And then your next question, does your value of F of 60 indicate that many students are 60 inches tall? Discuss at your group. So again, this should be something that you should be able to kind of determine from what's going on. It does not mean that many people are 60 inches tall. Just like when we were talking about yesterday, the everyone who got 5 hours didn't sleep exactly 5 hours. It's just that was the closest one. So if we are grouping these together by 5-inch differences, they're a part of that category, but they could have been 62, 63, 64, and that histogram that's in that 5 does not differentiate between those. It just says F of 60 is at this height. If you ask for F of 62, it's at the same height. So that's where we are for that entire column. Okay, important point, make sure you put this in your notes, okay? Because this is a big deal when it comes to the histograms. If you are interpreting a histogram specifically as a function, if you change those bin widths, you can make more than one function from the exact same data set. Okay, we're going to have a short assignment today. It's just posted here in Schoology, and it's only going to be, you look at that thing and you're going to go ahead and make your own copy. You can submit it digitally. If you want to submit it on paper, you can always turn that in on paper when I come back to class, and I should see you on Thursday.